Brett Clark, Global Director for Business Development at Blackshark. It's an honor to have you.
Good to be here.
Cool. So let's get straight in. What's the elevator pitch for Blackshark?
Sure. So the elevator pitch for Blackshark is that you do not have to be a data scientist to work with Geo AI. You don't need to know how to code. You just need to leverage our platform and know what you're looking at and how to color with a crayon. And in so doing, you can create geospatial algorithms that can eventually turn into 3D through our product data set. So uh, that's kind of my elevator pitch and usually gets people's attention pretty quick.
You've certainly got mine. You're reminding me of a cheeky question I asked during a session with the cloud native geo folks led by Jed Sundwall. And I was saying, what are you going to do for those who don't know coding and data science? And it sounds like, yeah, I've happened on a company that has an answer to this.
That's right.
Perfect. So can you expand a bit more on the niche that you are dominating?
Yeah, absolutely. So right now, the niche that we've been dominating is actually within defense and intelligence, which may sound unusual for a small company, relatively speaking, like ours. But maybe this helps with a bit of context. We used to be a video game studio. So Black Shark actually was created after a video game studio was approached by Microsoft to create Microsoft Flight Simulator 2020, the game. So we were actually the company that built the world's very first 3D digital twin for the entire planet. Kind of wicked.
You
And
guys are awesome.
thanks.
We are so lucky to have you. Like,
Yeah. Yeah. Pretty cool game, pretty revolutionary jump forward for the industry. And Microsoft invested in us and they said, look, become a different company, focus on like do that more. And so how we actually got started in that and how we built the digital twin was we quickly realized that AI was actually kind of a fallacy in the market. Like I usually say, hey, that means it's automated internationally because you send images, thousands of images overseas for low cost labeling, and then it gets dumped into a not unique technology, just standard computer vision machine learning systems that are still in use a lot today. And then marketing sprinkles it with AI and says, "Oh, hey, look, we've got something pretty cool here." Well, our video game studio based out of Austria, they said, we can't afford to do that. Labeling's expensive and time consuming. We're just going to build a quick annotation tool. And that's what's become our Orca Hunter platform today. So it allowed a video game designer to actually look at Bing satellite imagery and create global algorithms for building footprints, roads, and vegetation. And then what that did is it extracted the vectors globally that fed into our AI 3D engine that we built. And it got to the point where we could, based on wherever we were looking in the world, we had about, I don't know, 60, 70 different regional building grammars associated to it. We could detect a building footprint with a global average over 93% based off of thousands of control points. And we could automatically regenerate that 3D vector as a perfect polygon without like the mesh challenges you see from like a Google Earth thing. Uh, and we could do that globally every 52 hours, the entire planet.
you're reading
So
planets here.
yeah, yeah, that's
So you
planetary
used
scale.
this absolutely wild. So you used the term, I might have misheard you, but building grammars?
Yeah, yeah, good questions. I'll clarify that. So essentially, think of it as an equation, right? So region times archetype times other detected information plus randomization for the actual texture of the structure gives you a building. So that grammar, if you will, that procedurally generated
Yep.
structure. So you're in Atlanta, for example.
Yep. You can
Now,
see all the building footprints behind me, as
yes,
I, as
there's
I
all
always
the
mentioned in so many
yes,
episodes.
exactly, and
From
I love that
Microsoft,
view.
actually. These are Microsoft.
All right. Well, we can get into that. But the Atlanta landscape, while you might go through downtown Atlanta in Black Shark data and say, oh, that building actually is red, not green, right? It looks geotypical because what the system has said is This is a skyscraper in Atlanta, so the Southwest United States. It's above certain stories tall. It probably could look like this on the exterior. Now, the polygon and the actual geometry is correct, but the skin has to be procedurally generated because there is no global oblique data set that we could
Gotcha.
ingest for all
Gotcha.
those pixels. So that's building grammar.
Nice, but I just love your summary, I guess, of the state of the game or the state of the industry, and what you're nevertheless capable of doing. Yeah.
Yeah.
Okay. Amazing. So moving on then, how do you work backward from customer needs? It sounds like there was one to do with the world's only comprehensive global digital twin for a flight simulator.
Yeah.
Is that still the basic customer need, or have things migrated a bit?
Yeah, I think things have migrated a bit as we see that more in the market. Excuse me. So we're seeing simulation still be a strong play, especially with the active state of war along the Ukrainian front, in Israel, etc. And then obviously with the need here in the United States for more trained pilots and air traffic control, etc., flight simulation is still a strong part of the business, certainly. But what we're seeing is moving from just simulation to people saying, Blackshark, I really like what you do, your system for 3D visualization. Because there's some realities, in my opinion, with 3D data in the market. First, it's very heavy data. Secondly, it's very expensive, typically. And third, when people do get it, they don't really know how to use it. They're like, well, this looks cool. Conceptually, it's cool, but given the first two kind of challenges, how do I actually make this business viable? Ours is highly cost effective, and so we're seeing us be able to replace standard photogrammetric mesh, which is just a fancy way of explaining what Google Earth does in 3D, where the plane's camera overlaps with different angles, stitches it all together, and it looks real and looks beautiful until you zoom in. And then you're like, wow, this was all made out of chocolate, and it is the hot summer sun, and it's all melting. So ours is perfect polygons separate from the terrain and individual objects. And so it's very much analytical focused. So while the perfect photorealistic skin to the building isn't what we produce, the geometry behind it is. So we're seeing a market shift there for a demand in our approach, excuse me, to the demand in our approach to be more along the visualization and classic 3D use case versus purely simulation. That's where we see a
Okay.
shift for 3D at least.
Yeah. Okay. I so this is carrying on a bit of a thread, as tends to happen on the podcast between various episodes.
Sure.
Really going back to Stephanie May, and her efforts to. She sort of started out working on, the first global base map for Apple Maps. She was a part of that team, and then she was the one that led the team really to produce Facebook at the time, their first
Hmm.
global base map. And I continued that thread with Jordan Regine, who talked about the team who produced, I think, 70 3D cities across the US for Bing Maps, and then the global effort really via also Compass Data and Vexel, to
Yeah.
really produce this global base map for Bing. And now you are carrying on this thread also, it seems, related to Microsoft's efforts. Um, so there's that. There's also, I guess, the difference that you're highlighting between this mesh approach to producing 3D scenes. And another example of a company is Aerometrics from South Australia.
Yeah.
Um, but you're saying that a compelling product, something that you can sell, is, as I understand it, I could be wrong, please correct me, but to extrude the building footprints that your building grammar approach detects.
So that yes and no. So the system can extract a building footprint very accurately and then can understand a DSM. So
Yep.
between the DSM and the extruded building footprint, it can create a very accurate polygon.
Okay, so the digital surface model goes
Yeah.
over the top. That's as distinct from a digital terrain model, which is a bare earth model, as I understand it. So
Yeah.
just at the level of the building footprints, the tree base at the bottom of the tree trunks, the DSM goes over the top of the tree canopies, over the top of the skyscrapers.
Yeah. So if you think of this in mathematical terms,
Yeah.
right? If you're looking at a satellite image, that's XY, right? The DSM gives you a Z value, gives you the
Hmm.
height. So for every pixel, it has an XY coordinate, which is how we kind of think standard maps operate. But the Z value gives it its height position. And so the DSM allows us to see the Z value, and especially for buildings, because they are geometric in design almost always, that becomes very clear for a system to read. It's looking for right angles, it's looking for those geometric designs versus vegetation, which is more organic and, I don't know, globular in
Yeah.
nature, I guess
Yeah.
you could call it.
I,
So, yeah, that's how it operates.
I've got you. I mean, because I know as I understand, you're in London at the moment.
Yeah,
So a distinct building that deviates from what you would get if you just extruded the footprint skywards is the shard. The
yes.
shard is, essentially goes toward a point in the sky.
Mhm.
It doesn't go towards a flat roof.
Correct.
So if you just extruded the base of the shard, you wouldn't get the actual shape of the shard. So how my point is, how does the shard look in Blackshark's three digital twin?
Sure. So that's where a DSM is very helpful because the DSM will actually, because typically those are LiDAR derived, it'll register all the points
Yeah.
in between. So that's how we're able to get accurate geometry. Now,
Okay.
in some cases, I think so. The shard we can probably handle quite well, but let's think of something more like the Eiffel Tower.
Yeah.
The Eiffel Tower, that's more difficult to collect, right? So what we do is we say, look, there are some things and some use cases where uh, procedural generation just isn't going to cut it. Hand model that.
Yeah.
And we're actually seeing from, and we saw this with LA County, which is one of our customers for 3D. They said, we want to see what your system does out of the box for the Disney concert hall, which is a Frank Gehry design, very unique. If you've
Good
ever
luck
seen
with
it.
that.
Yeah, yeah. Frank Gehry
It's
is
designed to confuse these sorts of systems. Yeah.
that architect is allergic to parallel lines, but we and he said, I also want you to hand model that. And so we went and hand modeled it. And so we call those landmark structures.
Yeah. Yeah. Yeah.
So where there is a desire to say that's so distinctive, and there's actually precedence for this. We see this in Apple Maps, we see this in Bing Maps, where they will actually go and spend more time on a structure because the pure generation capabilities or the photogrammetric mesh return just isn't sufficient. It doesn't look good quality. So they'll actually spend some time hand modeling that. And that's okay, right? And we're okay with that.
Yeah.
So
It brings up all sorts of questions. I mean, another one, of course, is given that I'm from Australia, is this Sydney Opera House. Every Australian,
sure.
when they're
Yeah.
reviewing these sorts of systems, will immediately verify the quality of it by looking at that rendering. Um, Goodness. I mean, yeah, okay. Maybe there's a risk of me getting distracted. We've got some examples of how your system handles exceptions, and it's good to know, yeah, that you can comment
Yeah.
intelligently about that. I guess there's a whole rabbit hole here, but it brings
Sure.
up the question of, what proportion of buildings in a city are going to need to be handled in a bespoke way, and then it almost, to me, that helps understand the competitive landscape because uh, in a way, it almost would come down to, you would think, how efficiently companies like yours would handle those unique buildings. Um,
Sure.
and it's the most cost-effective way of doing that unique modeling, I think, that maybe is your competitive edge, I wonder.
Sure. So I think to address that and to go back, I think kind of two thoughts here. First, we have to consider how is that addressed today from the market as a whole, but also we go back to your kind of original question is it goes back to the customer need, the use case. So we have a lot
Yes.
of customers that are saying, I don't care about your textures. I don't care what it looks like visually. I care about the geometry. Like I care about the polygon, right? And why is that? Well, okay, I don't really care about the facade for flood modeling. I don't really care about it
Yep.
for wind modeling, or just pure visualization from like a planning for a major event, emergency preparedness perspective. It doesn't matter. It doesn't have to look exactly perfect to me, especially when I consider that Blackshark's outputs are lighter weight and easier to use and much more cost effective. I can deal with the how do I use this? Well, I can use it analytically. And I can speak to the fact that, okay, yes, I know your house is yellow, but this is blue. That's not substantive, right? But you also have to consider, how do people do that today? So either they run the system that they do, collecting overlapping photography, and it meshes together and they provide a globular thing that people have just been trained to be okay with from Google Earth, or they spend a lot of time and money hand modeling things to be precision. So that's kind of where we sit today. However, where we are going, and just since you mentioned you were Australian, I used to work at Nearmap. So
Ah,
I
there we
was
go.
in, yeah, I
We've
was
got an
employee
upcoming
number
episode with
7.
Chris Sams from Nearmap, by the way. But
Okay.
yeah, anyway.
Okay. Yeah. So I was employee number 7 in the US for Nearmap.
Ah, there you
So
go.
yeah, my first day was unboxing the monitors for our office. So we didn't even have our equipment set up. But so very familiar with them, Aerometrics, even Vexcel and EagleView will create the 3D the
Awesome.
same way. And we partner and work very well with EagleView and Vexcel, for example. Uh, that's still expensive to extract that data, and it's very heavy, right? So where we're trying to go is to say, why do people like Blackshark? Well, it's light, it's cost effective, and it's analytically focused. The buildings are perfect polygons. The assets that come in are perfect. They're video game quality. What's the disadvantage we have with our data? Well, we have to procedurally texture the structures. Now, hopefully what some of your discerning listeners will start to see where I'm going, and that is, what if we can take the good things about Blackshark and the photorealism from the standard 3D we're used to and combine those? And that's where we're trying to drive our technology, is to say, where there are obliques available, remove the procedural generation and put in oblique driven
Yep.
generation. In that, you get perfect structures, lightweight, cost effective, but now they're photorealistic.
Amazing.
Yeah. Where we want to take that a step further, because something we didn't delve into with our 3D, is we actually, even though we synthetically texture the structures, and we're wholly unique in the world in this, we actually create a semantic or material layer behind that to say, okay, we generated this structure and it has a brick facade with all these glass windows and a metal roof. Not only does it look like that to the human eye, but behind that, we actually create a material layer. What that leads to is sensor simulation. So if black ops are wanting to put on a VR headset and practice, going around an area and they have night vision, the night vision sensor will actually react with our semantic mode and reflect the way that that type of surface would reflect if they were there at a certain time of day.
Amazing. Yeah,
So,
the word semantic does come up a bit later on in an agenda item. So I'm
yeah,
glad you've flagged that. Okay, goodness. So in saying you're employee number 7 in the US for Nearmap, we are confronted with someone who knows the industry. So yeah, again, really glad to have you on, Brett.
for sure.
All right. So, last item, sort of characterizing the business before we start to dig into some specific products or services.
Sure.
So, what's the skin in the game of owner management staff, and how's that translating overall to the speed and stickiness of growth of Blackshark?
Sure. So our CEO is the co-founder, and he is involved every day. He's out with my boss right now, actually in the US, actively selling, speaking, and driving growth. So we are we're about 90-ish people right now. That's probably the smallest we'll ever be. And so he's actively engaged, fully involved, and that really speaks to the culture, but also how we operate as a business. And that's been really encouraging. And he's really respected, obviously, in the market. From a growth perspective, we're excited because as we get the word out about what our system does, we're seeing a lot of momentum because we're essentially proposing to the market a paradigm shift that they've kind of subtly wanted, but haven't really been comfortable making yet. And in my estimation, the way I kind of boil that down is you have people that are builders and you have people that are buyers. So I see this a lot in the insurance market, which is actually where the semantic layering will play heavily if we get to that later in our discussion. But a carrier either just wants to be given insights and they don't want to do any work. And I'm overgeneralizing on purpose, but and that's where someone like a Nearmap can play very well. And Nearmap's been very successful in the insurance vertical uh, because they say, "Oh, here's the pixels," and then we went and extracted all the things we think that you would be interested in. Just license the data from us. But then you have others that say, "I don't want you to know how my sauce is made. I want to do it myself," right? And so the traditional approach is data science team, machine learning analysts, all those things. Well, what we're saying is you actually don't need all of that investment. You can leverage our no code platform. And we now have made the barrier to entry much lower, next to nothing, to build it yourself. And what that allows is for them to always own their data, never expose that to a third party, and now they can operate way more efficiently and have better margin from that. So I think that's how it affects the market for me and why the message is resonating so well is we've made it more effective for you to build versus buy, and you get to own your data always.
Okay, so is it that effectively you guys have got a compelling global 3D digital twin of this planet? The question is, which one's next?
The moon.
But yeah, and that's what we all want to see. Um, but also that the system or tooling that you've developed to produce that digital twin, you're licensing to others to use their own data about the Earth or a part of it to produce their own digital twin. Is that what you're saying? Or am I misunderstanding?
No, you're correct.
Okay, cool.
Do it yourself.
Great.
Yeah, we
Yeah.
we very much come in when I talk with people, like I just presented yesterday with one of our partners, Capgemini, here in London. And my message is always the same. We come in to a sales engagement, a conversation with two basic assumptions about you, the customer. And that is you have people internally that are very smart. They know what they're doing. They know what they're about with their business. And we also assume, based off our experience, that you have your own pixels. Now, that could take the form of drone data. It could be street view. It could be just images from your phone. It doesn't matter. Our platform, Orca Hunter, the no code interface, pixels are pixels. So if it's in raster form, it does not care about the angle, orientation, resolution, number of imagery bands. It doesn't care. It is a cookie monster of pixels and it'll eat them all, right?
Um,
So so for that we
that's going
say,
to be
look,
the quote for the episode.
okay, perfect. And I'm wearing blue and I love cookies. But it's very true. So we kind of say, look, you have the power within you and you already paid for the pixels. You've paid for the people and the pixels. Our platform allows you to fully unlock both of those. And where we're unique is that in so doing, by combining those two, that leads to insights. Now, that could be vector information, raster information, whatever. And those are always yours too. So it's your people, your pixels can combine to be your insights. And we're simply a platform that you license in the middle. And so that message resonates very, really well across defense and local government and insurance and everybody because they're like, yeah, we do know what we're doing. Yeah, we can do that ourselves. Right. And then cool, I don't have to keep paying because I'm using somebody's data. So the industry, I think, got a little happy selling or licensing data to everybody because they kind of were like crack dealers, like, yeah, you need another hit, we'll keep selling it to you. And we're saying, no, maybe I should change the drug analogy, but
I love it.
you,
Keep it
you
going.
can
We've
you
got
can
Cookie
actually grow it
Monster and now
yourself.
we're into drug killing. This is the best episode. We need to use this language all the time in our industry. Then people will listen.
Maybe,
Now,
yeah, I'm
now I
actually.
understand what it takes to be the global director of business development.
Well, so it's kind of funny because the video game studio that we came from is called Bongfish. So
uh,
we kind of
you
are
got.
feeling a thread here.
We have to get more people from your team on. Use that really, really fun.
They would be much more entertaining than I am, I'm sure.
Okay. So you're referencing all of the next agenda items, so I think we should just
Yeah,
get on with the next one.
for sure.
So tell us about version 2 of your AI terrain generation platform.
Yeah. Yeah. So V2 is really interesting because, again, where we've shifted is versus just purely licensing the planet to someone, which is very expensive because you're talking about 3D for the entire planet. We're migrating more towards this is an engine that can consume your own data and produce the output you want. And so that's
So
kind of
that's
where we
what,
sit
sorry
today.
to interrupt, that was what you were kind of describing already. And now we're just putting a name
Yeah.
on what you were describing.
Yeah, yeah, and then also being able to handle texturing better, handling things like physics-based lighting and reactivity and reflectivity better. We have a very strong plugin with the Unreal Engine.
Yeah.
Fantastic group of people, fantastic platform, and it really can bring our data to life if you've used Unreal uh, for anything you would want, from their ultra dynamic sky to weather conditions, etc. What we're able to do is put in, let's say lamp posts, and then in a city scene like in London, turn it on to night mode and have randomization of lighting in the different buildings. And you can increase or decrease that and have it reflect off different surfaces more accurately.
This is
So you get
wild.
true
Y-
feel. It's coming back to our video game roots. It's like it's got
Yeah.
to look as real as possible, right?
You guys can basically just animate the world.
Yeah, we
It's
can. Yeah.
wild. I love it though as an advertisement for our whole industry and discipline.
Yeah.
I think it's really important for the outside world and even students to know that this capacity exists and to inspire people.
Absolutely. You bring up a very interesting point, Wilfred, because two thoughts. Yesterday, I thought this was very interesting. I was talking with a group of folks, and they said, what really got some people after 9/11 to be recruited into the service was the fact that they were seeing drone pilots fly with Xbox remotes. And that was a paradigm shift. And it seems like a small thing, but the average kid who had been like obsessed with Xbox was like, wait a second, I am really good at I could translate that skill, right? And that lowered the barrier to entry because it kind of opened up their mind like, no, I don't just have to dig trenches and carry a weapon. There's a place for me, and I want to serve my country. I was in California 2 weeks ago meeting with college students, and I didn't know this until my colleague shared this with me, who happens to be a former Army Ranger uh, and was in our headquarters in Graz, Austria. He was telling the class because they were asking about 3D. He said, our team in Austria actually interacts with our 3D with an Xbox controller. That's their primary form of navigation through it, not with a mouse, but with a controller. And it was this kind of, oh, wow. Like you could see the aha moment in the students' eyes. And in talking with them and their professor, who's a good friend of mine, uh, he kind of said, "This is becoming like I see Blackshark as the gateway drug to GIS."
Yeah, yeah,
And
that's
it
what I
was
mean.
very, yeah, it was very interesting to hear
Continuing the drug use
yes,
references.
I know, yeah, exactly.
Brilliant.
Continuing,
Inject geospatial into my veins. No, sorry,
just
sorry. Let's go too far.
tap it in. So the in talking with the staff, and the faculty, they said we have seen a decline in geography majors. And they said, as we talked, they were saying, we think it's because we make it too hard and the barrier to entry is high. We're not letting them really do fun things until a 300 level course. But if we can present something like this to them that says, look, it's simple, it's easy, it's actually fun. Like it is
Yeah.
fun to use our platform. You get lost in it. This would lower the barrier to entry and help people understand GIS is more than just maps.
I mean, when I was, I don't know if you've heard of Q Sheng Wu. He's a
I think
professor.
I think I
Yeah,
followed him on LinkedIn. Yeah.
yeah, me too. And he just spits out all these wicked Geo AI tutorials, and DuckDB is sort of, he is like he lives inside of DuckDB. Um, and I just, I, in response to one of his posts, I basically, because he is another great advertisement for our industry. And I tried to sort of summarize what he was showing what we could do as essentially putting a planet under a SQL query. But it seems like what you guys and your industry does is put the planet under an Xbox controller. And basically we have the world's largest, is it, I forget the gaming terminology, but it's like an open world universe type thing.
Yeah,
Um,
metaverse, I think.
is there some term that relates to what I'm trying to say here? Because
I think
some
a lot
game,
of
it's like
people,
GTA, is what
yeah,
back when it was first released was, and maybe the later versions is like a massive explorable world. But you
yeah,
guys have the entire planet, but
do.
it was made for flight simulators. But what would be cool is to have, you could control a vehicle on the ground and go on all the streets of the world amongst all the buildings of the world. Anyway, so that to me is how
Yeah.
it can be exciting to people.
Oh yeah. Well, so we've been involved with Omniverse. So I think you're kind of referencing like verse. There's metaverse, there's Omniverse. We've worked with NVIDIA on that to make it realistic at the ground level. Because you're right, it's and ground level data is harder to ascertain at scale globally, right? So that's why, from a flight perspective, it was, I won't say easier, but more achievable. So working with NVIDIA to create that kind of world verse. I think with the term people are, they put whatever their term is and then they verse at the
Yeah.
end, and that's the planet. Woo! So yeah,
Buzz, hype.
yeah, it is interesting though. I have a confession. I troll him a little, not like in the standard
I'm
sense. I
down for
stalk
trolling.
him a
There
little
needs to be
bit
more distance
on
and trolling in
LinkedIn.
geospatial. Go for it.
I troll his post a little bit because he says, look, with just a few lines of code. He says that every post, few lines of
Yeah,
code. And I'm always like, you don't need any lines of code.
right. Yes.
uh, and I think that's how we might have actually got connected, because I saw one of his posts and I saw your comment. I said, hey, that's a really cool comment. We should talk.
Okay. Yeah.
But
There you go.
yeah,
Thanks, Q-Sheng.
yeah. But and I like what he does. I find it interesting. But I think, what if you don't know how to code? What if you never want to know how to code? And that's something we get asked about. Well, what
That's me.
about right? Yeah, like I don't know how to code. And this is the interesting thing. If we go to a, let's talk about defense and intelligence, for example. Let's say I'm some operator who says, look, I was deployed by the CIA in Syria for 5 years. I know exactly what a power pole looks like in Syria. That's very different than ours here, right? For example. Well, that's probably the best person to create an algorithm to identify Syrian power poles from imagery, right? Is there anyone better? Unless you got a Syrian? No. So, what our system says is, hey, you, subject matter expert, you are the person, you're the expert in the loop. Leverage these pixels to build an algorithm to then transfer your knowledge into a system that can look at all of Syria immediately versus looking at tile by tile. And that's what our system does. It takes the subject matter expert and combines them with data science seamlessly, so that it's as simple as using Microsoft Paint to create an algorithm. My 12-year-old daughter built an algorithm, okay,
Amazing.
in a few minutes. So,
That could also, that's another great way to really inspire people, I think, because it's hugely intimidating data science, and at the REPL, trying to cobble together the right syntax, and then fighting through the syntax errors, to finally get a simple script. So yeah, to essentially unleash using a simple interface, machine learning sounds like, yeah, another great way to inspire people.
yeah, and that's, I mean, we're seeing that with the chat GPTs and Groks of the
Yeah.
world. It's, how can I speak to an advanced
Yep.
system the way that I speak and have it understand and pull things back? And look, it's not like AI is magic. So it does not change the classic statement that bad data in, bad data out, right? I mean, it can kind of maybe smooth the edges a little bit for you, but at the end of the day, rather than just purely saying human in the loop, we really focus on expert in the loop.
Yep.
So we're here to not replace people. We are here to maximize the inherent potential they already have and the hidden value in the pixels they already have.
Okay, full of fantastic, simple phrases. I can tell you do this all day long.
A
Okay,
little bit.
awesome. So you already mentioned the term Orca Hunter. Could we have a
Yes.
couple of minutes or some extra detail on that?
Sure. So, and I do not know where the name came from, nor do I know where the name Blackshark came from. Okay. I
I
think,
like the theme though.
yeah, I think that they just felt it was cool. And I think they are cool. But Orca Hunter stemmed from building the digital twin. It was our answer to not have to pay annotators. And it's evolved over time. So, Orca Hunter is a system that allows you to ingest any type of raster pixel information and create your own algorithms in a no code environment, and will also batch process across entire data sets for you. What it can also do, well, I guess I should back up, which means you are able to not only identify objects, you can classify objects and you can segment information simultaneously. You can also identify changes because we have an entire change detection aspect of the platform. What's unique about that, and where we differ from anyone else in the world, we really have found our change detection platform is different from anybody else in the world, is that most change detection, A, is manual, B, is wholly reliant on existing data sets. It's like I feel like I'm calculating slope, right? From whatever, freshman year geometry or something. And that is I have building footprints from 2025. We'll call it B. And I have building footprints from 2024. We'll call it A. Well, B minus A equals change, right? And that's how change detection occurs. What if you don't have that data? Or what if you need some different type of aspect of that data? I don't just want to see changes in buildings. How many buildings have been built in my city that have asphalt shingle roofs? How many of them have degraded in quality? Right? There's an unlimited number of things that we need to understand across multiple industries as it relates to change. So our system allows you in real time to pick out the semantic change that you're looking for. So the
So,
material change.
yeah, this brings up another thread that we had over a few episodes, prompted obviously, of course, by the Palisade fires. Were you involved at all with any of those efforts to characterize for insurance companies the number of damaged buildings?
I'm really glad you asked that. So this is a very interesting story. We actually worked with the county on that. So, as I had mentioned earlier, they were already a customer of ours. I guess I should say this is no way an endorsement by the county of Blackshark, but this was just our experience with them. And they said, "Hey, we really need some help. This has been quite devastating. We want to see what can be done with your system to help us understand where are the damaged buildings." So they sent us pre and post imagery of the Palisade fire, the Eaton fire, right? All their fires that they had. And one guy on our team, our solutions director, said, I'll handle this. And he took both data sets and he built a model to extract the damaged structures. He took the building footprints provided by them and then basically overlaid the damage with those building footprints to basically say, look, the model's just looking at rubble, but now kind of snap that to your existing polygons that you have. And he discovered an error. He's like, well, I don't understand this anomaly. And then he realized we are finding damage in places where they don't have a record of buildings being.
Yeah. Wow.
These were hand drawn structures. Okay. So then he said, I'm going to run our building footprint algorithm
Yeah.
and see where stuff is missed just in the fire affected areas, not the entire county, but just
Yeah.
the fire affected areas. Our system found over 1,000 new buildings that
Oh
their
my
data
God.
set did not have.
This is the county. Okay.
Yeah. Of
This is the
those
power of
thousand,
data science and yeah, reading the planet. Yeah, that we have. Yeah.
exactly,
Incredible.
exactly. Of those 1,000, over 30% were damaged. Over 300
Oh my
structures
God.
were
So they were
damaged,
missing entirely. Right.
missing
They
entirely.
went away. Yeah. Okay. Amazing.
Yeah. So there are 300 buildings they didn't know existed that were destroyed.
Okay. Wow.
And so he packaged all that information, including the model, and deployed it to him in 4 hours.
Amazing.
All of that took 4 hours. One person.
Yeah.
So
one
I met
person.
with them when I was out there a few weeks ago, and they said, so far with the data that we've reviewed, we had to send people out with clipboards or iPads into the field and walk every single one of these. And so far, your model's been above 96% accurate.
Okay, good.
Think of the time savings, the money savings, the risk. I mean, think of the air quality and other things out there with people
Yeah,
walking the site,
exactly.
right?
You got it.
That was done by one person on a computer within our system in 4 hours. All of that.
Hmm.
So now that has bled into insurance and other things. But I'll caveat that there were several companies that brought data to the county, like, oh, look, hey, we're
Uh,
doing this out of the pure goodwill.
the blooming of
Yes.
solutions and posts on
Yeah.
LinkedIn that I tried to keep up with, and that led to several episodes. Yeah, I
That's,
understand. There was all the AI for good posts, which I appreciated from Microsoft and Meta, I
yeah.
think.
Yeah. And we purposely didn't do any of that because we
Yeah,
were like, we don't want to seem like an ambulance chaser.
yeah, yeah.
Uh, and the county asked us not to. We said, well, we'll respect that. We're just going to help you directly. And so they used us as the authoritative kind of data set from a geospatial perspective uh, to at least kind of review and get started. So that's
Oh,
how we
amazing!
were
What a
involved in
privilege
it.
it is to have you then again, even more so. Yeah. Okay.
So
Wow,
yeah.
Brett.
So that's Orca Hunter. It unleashes the inherent potential in people, and that's what it's intended to do.
Yeah, I really love that. That this has emerged from our industry and that we can offer that level of empowerment. Okay.
Yeah,
So I flagged that we would discuss the word semantic in this agenda. So you have a 3D semantic map. What is the significance of the word semantic?
sure. So the significance there, I think, plays across a wide variety of use cases. If we think of energy resilience or climate resilience and the environmental impact, understanding how buildings reflect heat really comes down to the type of material, right? That's why a green roof is more appealing from an environmental perspective than a standard roof that we would see, especially on a commercial building. The vegetation absorbs the sun. Well, that vegetation is a different material, substance thing than the standard roof you would see. That's also why you see more commercial structures having white roofs that are laid out commercially than the traditional black or aggregate because it reflects heat back. Uh, for example, when it comes to insurance, understanding the building not only that they insure and what it's materially made of, but the structures around it are useful. I'll give you an example that when I was at Nearmap, I came across. There was a carrier that did a lot of commercial structures, and they said we want to understand not only our building and the heights of our building and the material layers of that, but the structures around it. Because if the structures around it have an aggregate roof, and what I mean by that is sometimes you see where they have the big chunks of gravel as their roof, kind of odd, but they have it in a lot of places.
I never
In the
knew about
event
that.
of, yeah, yeah, there are some roofs where they just have big, thick chunks of gravel on top. They're like smooth stones.
Interesting.
I don't fully understand why that is, but they do.
Sounds like heavy roof.
It's a very, very heavy roof. Uh, But they said, look, those pose a risk to our structure because if our structure is 30 stories and it's glass, and there's a couple of these buildings nearby that are 10 stories and they have that aggregate roof, in the event of high winds, that's like grape shot hitting our building.
Oh man.
So we can't handle that, right? So understanding the material aspect of things is very important. It also helps them ensure the property and be more accurate in their premiums to say, look, this building's made of
Got you.
stone or something.
So,
Uh,
so is the use of the word semantic effectively that in reading a planet, you can put words on parts of the planet, and by putting words, by deriving meaning from the pixels and expressing that meaning in words, you can somehow read it on a deeper level. I'm really not describing it effectively. Can you help me here?
Sure. Yeah. It essentially, yes. It means that every pixel gets a label,
Right.
basically. It gets a definition. So that for us, we
I'm just
kind of
trying to
use those.
understand why the word semantic is used. Sorry to cut you off.
No, it's okay. It kind of translates across a couple different use cases. Uh, just semantic can mean different things, not just like syntax related to, words and things, but semantic meaning everything is given a material definition. And so for us, what that means is the actual physical material that it represents. Every pixel represents some sort of physical material.
Okay, so you can literally pass the world for the gravel roofs.
Yeah.
And you could make, in the SQL query that can be used to access every square inch of the earth, you could put in some sort of in your no code interface, you could straightforwardly pull out the gravel roofs of the planet.
Hmm. Yeah.
Okay. And I can understand then, yeah, and given the meaning of those gravel or aggregate roofs to insurance companies, the power of the product in their eyes. Yeah.
Yeah. Well, and this bleeds into a lot of other use cases too. Let's think of a Department of Public Works or Department of Transportation. How are our roads doing? Where are their potholes? Where are their cracks? Uh,
I remember
I,
doing those surveys on the ground with a scooter and a differential GPS
right?
antenna and taking 3 months during the summer heat in South Australia to do that manually. So we're at the stage now where that job perhaps isn't needed.
To a certain level, to a certain degree, depends on how good your input pixels are.
Or it's ground
Uh,
truthing the result. Yeah,
sure, yeah.
from
Instead
yours. Yeah.
of instead of the opposite way where it's I'm going to ground truth everything, it's more of let's and that's kind of what we're hoping to do with our system is nothing will replace like you and I looking at something, right? That's just kind of the nature of nature. But if we can take the amount of some things you and I have to look at and aggregate that down to just the most pertinent things, then we're getting somewhere, right? We're creating some efficiency and some productivity. So I remember working with a city out in North Carolina. They said we actually have a coefficient of degradation for our asphalt. I said, "Whoa, guys, I'm in sales. You gotta explain some things to me." Uh, and they said we basically have mathematically calculated how to classify asphalt. Like how bad is it versus how good is it? And essentially came down to we have, you know, freshly paved, great condition, good, fair, poor, yikes, maybe shouldn't drive there, right? Essentially.
Potential
Well,
sinkhole.
yeah, potential sinkhole. Our system, you could create a model that could extract all of those types of pavement to say, find me where all the freshly paved roads are. Now find all the roads with cracks in them. Find all the potholes, right? Those things matter. Those have material implications, just like finding those 300 plus structures that have burned. Well, why does that matter? Okay, we found 300 more buildings, no big deal. Okay, well, that's potential fire and rescue issues. That is hazardous cleanup because if it rains, which it did in February and March in LA, you have runoff of hazardous materials that's a lot of material you didn't know about that you
Exactly.
now have to put into your model. That's 300 plus more structures to dump into a landfill.
Yeah.
That's how many more truckloads, how many more working hours, like man hours and things
Yeah.
like that. Like this has real dollar implications. And so understanding those materials and understanding the semantic layers are helpful. So there's a whole host of use cases for
Yeah.
that.
Yeah. I am beginning to understand. Yeah. Cool. But yeah, there's a lot to explore, I think, more with that. But yeah, thanks for introducing us to the basics. All right, we've got a couple of minutes left. The last question is what you're looking for in new hires.
Good question. So I won't deign to speak for our our engineering team or developers, though I think we're looking for people that embrace AI in their workflow, that use those types of tools to make them ultra productive. I think from a cultural perspective, we don't look for egos. I have enough of one for the company. No, I'm just kidding. I'm just kidding. No, we look for people that understand uh, kind of our ethos. And it really came through to me when I talked to our head of engineering for our Orc Hunter platform. And I was talking to him about something a customer was asking for. And he said, I really want customer feedback. And I hear that from engineers a lot. I said, oh, okay. He said, no, if our team isn't creating value for the customer, we're wasting our time. I want to know what the customer wants and how they want it. I was like, whoa, okay, this is a different mindset, right? So we want people that are passionate about what they do, they seek ways to be effective, and they keep the end in mind. Like we don't just engineer things because they're cool. We engineer things to make a difference to our customers, right? We want to make them safer, we want to make them healthier, more effective. Whatever aspect of life that we can touch for them, we do that for them, not just because we're egotistical or think it's cool. That comes after. But that's the type of people we look for. And candidly, certainly from a sales perspective, my purview, I look for people that are hungry. This is not a place to ride the train. This is a place to not to be too punny, but to really hunt. Like we're out there, we're aggressive. We are the sharks in the water. We have a couple companies we look at and we say, we're coming for you type thing. That's who we are looking for is people that say, look, we really want to change the world. And our message is, well, we understand the world because we recreated it. And so
I love that.
help us change
That's a great,
it.
another great tagline.
So
I
thanks.
feel helpless with your what can I say, well crafted sales speak, Brett. But no, what can I say? There's a reason I have in every single episode how you work backward from customer needs, and that the awareness of the meaning of that question is evident throughout your responses. Wow. Okay. So yeah, the guys behind Microsoft Flight Simulator 2020 and everything that's flowed from there. It's amazing, Brett, what you've described, and yeah, you're a poster child, if uh, uh, to use another cliche term, for our industry. So thanks for doing that for all of us.
You bet.